Hi, Shraddha. So yes, please let me know if you have any questions from the previous classes. Can you hear me?
Yeah, hi Jalaj.
So yeah, you have any questions?
Uh, Only one doubt, Jalaj. So in the import section, we have this from date time import date, right? So what is this from date time?
It's a library in Python. So it's a complete datetime library, and from that, I mean, it has multiple modules, and we are just importing one of those. So if you haven't worked with Python, I mean any programming languages. So in programming languages, we do have multiple libraries. Okay. So to make program lighter, by default, not all the libraries are loaded in the compilation time. Okay. So sometimes, for this program, we need datetime library. Hence, we are importing it. If we import all the libraries unnecessarily, our code execution will get slower. This is a general practice in all the programming languages. And like Python also supports web development, it supports machine learning, it supports data engineering, it supports application development, it supports backend development. That's why if we import all the libraries by default, all these libraries will be imported. So data engineering guys import data engineering libraries, machine learning guys import those libraries, required libraries only.
Okay.
So I'll just share my screen and open the
Yeah,
XML.
is Karthik and not joining?
Karthik pinged he is going to be late by 20 minutes.
Okay.
Okay. So for today, we are going to make a simple flow of a program. Okay. So it's going to be a bit more complex than previous one. So what we are going to do in our S3 bucket, we are going to upload a file. Okay. We are going to upload a file on our S3 bucket, and with trigger, a Lambda function will be triggered. Okay. This Lambda will identify file type. Okay, what kind of file we have ingested. So we are expecting two of those for now, a PDF file or a image file. Okay, once this identify the file type, it's going to trigger one more Lambda. If the file type is basically your image type, we are going to trigger a recognition Lambda. Recognition is AWS service. I'll let you know about this. And if we are triggering a PDF file, we are going to trigger textract Lambda. So for this one, this demo, we are not going to go through this flow, okay? Because idea here is not to understand machine learning or understand text analysis, all those things. Idea is to work with some flow and do some transformations via Python codes in Lambda functions, okay? So once the output of these two lambdas are generated, it will be saved on a file and it will be on S3 output location. Okay. So I'm just going to reiterate this. We will upload a file in S3 bucket based on a event trigger. Okay. How to set up a event trigger? We will see. Based on a event trigger, we will uh, trigger a lambda. I mean, this S3 upload will by default trigger this lambda function, and this lambda function is going to read through the data and it's going to identify which file has triggered me, and accordingly it's going to trigger the next file. So for our case, it's going to be an image file. So we will trigger this recognition lambda, and this lambda is going to work with AWS recognition service. Okay, and that's results. Whatever the result we get after that recognition service output, we are going to place those results in a CSV format on a S3 bucket. Okay, so do you have any questions in the context?
So if we are uploading an image, how are we going to save it in a CSV?
No, we are not going to save image in the CSV. This recognition lambda is going to give some outputs. Okay, let me go through here first. AWS recognition. So AWS recognition is basically a machine learning service provided by AWS to do image analysis. Okay, so it has a variety of image analysis. We are not covering that completely. Just for this demo, I'm going to explain you label detection. In label detection, what happens? In label detection, what happens? We just simply pass an image into this service. Okay, let's say I click on upload image. I upload this image of Pepsi can, and you can see some results here. Okay, basically machine learning is identifying what all we have in this image. So we have a can. There might be a tin based material. It might be from beverage industry. It might be a soda, or it might be a Coke. Okay, so we get these two results on a result page, and this is we are going to save in the CSV format. And then also we have the confidence percentage, like how much percentage ML algorithm is sure that this model is confident. Okay. So this is AWS recognition service. Okay, so it's a very simple service. If you use this image, it's going to give analysis for this image like architecture, building, city, urban, metropolis area. Some office building might be there. This image has water. It has some waterfront as well. High-rise buildings are there. Okay, so like that, basically, it gives you the outputs on the right-hand panel, like what this image contains. According to it, you can use it further. So, any more questions on this one?
This is used only for images, right?
Yes, it is
Recognition.
only for, I mean, no, it is only for image analysis. It is for facial analysis. It is for face comparison, celebrity recognition, text in image, PPE detection. This is the ability in Corona time to detect PPE if somebody is wearing PPE or not, like that. So it's kind of, its use case. If I give you now, let's understand this PPE detection only. So this they built separately in the Corona time. So it's going to continuously sending the images to the server, and it's going to monitor whether the doctors and the concerned persons in the premises are wearing PPE kits or not. Or you can send, you can also customize this. Let's say the factory, you say these are the positions of my machines and these are working fine. And if recognition checks some differences, some wear and tear in those machines, it's going to notify that your machines are having some wear and tear, or somebody's doing some malicious activity like those. That is the use case of this service.
Okay.
Okay, sorry. Yes, so we will set up our bucket. So if I come on S3 bucket, I have my S3 bucket here. I will open a Lambda function. So in my S3 bucket, okay, I have, this is my S3 bucket. Okay, I'm going to use this bucket for this demo. I have two folders, source and target. If I come on Lambda functions, I have to look for file identity Lambda. If I open this Lambda function, so to create a Lambda function, okay, what you have to do, I think I missed this part in the last class. All you have to do is create function, okay, provide a function name, something, provide a runtime, choose Python. In the here, I use existing role, okay, and choose a IAM role that has been created by you, okay. So for this one, I think I'm using recognition access, the recognition S3 access, because we need access to recognition service also, and we need access to S3 service also. So that's why I'm going to use this one. Clicking on create functions creates a Lambda function for you. You will get a empty, you will get a boilerplate code only. Okay, In this section, you will get some boilerplate code that will have simply a Lambda handler and it's going to print the event. Now, for this demo, in the configuration part, I am using a recognition access role, and this role has these permissions. You can take a, I mean, it's recorded, so you can make sure that you have these policies attached. All are AWS managed policies, recognition full access, S3 full access, Lambda basic execution role, and Lambda role. Okay, these are the 4 policies that you will need. Then next thing that I have done, I have created a trigger. So what I will do, I will remove this trigger and delete this. So what basically trigger does, okay, let's say I want to run this function. Okay, let's understand this use case. Okay, in my bucket, a file can arrive at any point of time. Okay, I'm not sure whether it's going to come in morning, it's going to come in afternoon, or it's going to come in evening time, or it's going to be placed in one time only, or it's going to be placed multiple times. But what I want to make sure that whenever the file arrives in my bucket, I want to run that Lambda function. Okay, so for such use cases, we will have triggers not only for S3. You can see on the Lambda page, if I click on add trigger, it's going to ask me a source, and that source can be all these technologies like Alexa, Gateway, Code Commit, IoT, CloudWatch Logs, S3, SNS, Kafka. All these kind supports event-based triggering of Lambda functions. Okay, so for our use case, we are going to use S3 service. And then it's going to ask the S3 related questions like which bucket you want to use. I will say Lambda mini project. This is the bucket that I would like to use. Then what kind of event type you would like to use? If you drop down this, you can see you have all object create events, you have all object delete events, or I mean you can also choose the specific delete event. So whenever your file is getting created or moved into the bucket, or you delete the file, or you delete the version of the file, or you restore from the Glacier, or when the restore is initiated. Okay, so in all these cases, you can schedule a event. So for our use case, we want to run this file when the all object create events is actually triggered. So I'm going to keep selecting this one. Okay, then we have prefix. Okay, this is very important. This I also skipped in the lifecycle rules. So whenever you see the prefix, basically you use prefix to restrict the access, or you can say restrict the amount of data you want to use in S3 bucket. Okay, so if I mention nothing here in this prefix option, if I keep it empty, whenever I place a file inside this Lambda mini project bucket, okay, whether I create a new folder and place the file, or whether I place the file directly here, or whether I place the file in source folder or in target folder, in all such scenarios, my Lambda function is going to get triggered. Okay, in all such scenarios, my Lambda function is going to be triggered. But what I want to make sure that it is only triggering where the file is arriving in the source bucket. So I will simply type source here. Okay. So now if the file arrives in target bucket, or if the files arrive outside of source bucket folder, or if the file arrives in the other folders, my Lambda function will not be triggered. Okay. So then we have suffix. Suffix is basically, as you can see, example .jpg. So if you want to restrict your files only to be CSV, only to be PDF, only to be docs, or like some certain suffix you want to use, in that case you can provide those suffix. So for now we are just simply providing prefix. We are not providing any suffix. Then we have a recursion invocation warning. You have to acknowledge this. So basically what we are here, this is saying, if you use the same bucket, okay, as it says, if you use the same S3 bucket for both input and output, okay, in that case you have to be very cautious. Like it means, like if I use the source bucket, I mean if I use the same bucket for my input and for my output as I'm doing here, okay, then I have to be cautious. Cautious where? then I have to make sure that I am making a prefix here. Okay, I am absolutely, I have to, mandatorily make a prefix here, and in this prefix folder, okay, in this prefix folder, I cannot write any file from my Lambda function. Okay, so what I'm trying to say, let's say we haven't added any prefix. Okay, let's say we haven't added any prefix here, and we are simply waiting for the input in all the complete bucket. So whenever the file arrives in the source folder, okay, it is going to trigger my Lambda function. My Lambda function is going to analyze that file and it's going to write the output on target bucket. But as we have no prefixes filter for triggering, again from the target folder, my Lambda function is going to be get started. Again, it's going to write the output in the target bucket, and again it's going to get started. So it basically, this is going to be an infinite run of the Lambda functions, and it's never going to stop. And unfortunately, we will have to pay the charges accordingly. Okay. So we'll have to be very cautious here on this point. So I will click on the add once you, let's say, if you're good with these things. I will just pause here.
So the suffix would be like the type of file we are uploading, right?
Yeah, I mean, it can be any name also, like let's say your file name is, what I say, sales data. Okay, this is the file name, so you can add suffix like this also. If your file is not containing any format, that you are only looking for data file, you're not looking for any other files. Suffix can be anything that matches the last character of your file. This .jp is just an example of those.
Okay. And the events we are selecting here, Chalish, can we also create events, or these are like we have to select from default ones?
No, we have to select from these only. So this is actually connected to Lambda functions. I'll let you know how. But I mean, this is all good. You will not need any customized events here. These are all events that you can think of, like creation of file, deletion of file, and removal of file, and those things all. I mean, what else you can think of?
Okay.
Okay, so I'll add this trigger. Okay, so this is successfully added. Now we have the trigger again here. If I come back to my code now, so this is my code. So what we have done till now, we have S3 bucket. We have two folders inside this. We have restricted the triggering of the Lambda only for source folder, and also, yes, I mean, obviously we have added a trigger to this Lambda function that whenever the file is created in that folder or moved in that folder, it's going to execute my Lambda function. Okay. Now comment this code. Okay, I will simply print one statement, and we will print event. I'll copy this, come back on my code editor and paste it. Okay, so right now what we are doing, we are simply receiving an event. So see, when S3 triggers the Lambda function, okay, when S3 files actually triggers the Lambda function, it sends some input also. Okay, it does send some input also, and that input is actually saved in a variable called event. Okay, and this is true for all the sources, whether you are triggering it from DynamoDB, or S3 or Kinesis or Kafka or whatever else, whenever some other third application is triggering the Lambda function, it is going to pass on some event information. Okay, so we are simply going to print that information. And now we cannot click test here. If I click test here, okay, I will not receive the correct information in the event, because I mean it will work absolutely fine, but it will not receive the correct information in the test in this event print, because we have directly clicked it and we want this to be get triggered from S3 bucket, so we can get correct information. So I'm just going to come here in this folder. I'm going to choose this file can.jpg and move it in the same folder. Okay, so basically I'm going to create a copy paste action, and the paste will recreate the file in the same folder. I'm choosing the same destination. Okay, Lambda mini project source folder, and I'm going to move it. This moves my object. Okay, now if I come back on my Lambda function in the monitor part, go on CloudWatch logs. And this is the stream that has been generated on 25th November 1822. And this is the result that we have got. Okay, this is the result that we have got. Let's format this. And let's create this in the Jupyter notebook. Okay, so as we know, all the responses given by Boto3 are dictionaries, and this is the response that we have got actually. Okay, ignore all these steps, this thing. Okay, this is just visible here. You can ignore this, but this is exactly what we have got, and this is the event variable. Okay, this is the value of event variable. That's why we were able to print these details. What details we have? We have records, event source is S3, what region it is, what time it is, what kind of action it is. So it's a copy event. Okay, as we have moved the file. Okay, then we have a bucket name, we have object type, then we have ARN of the bucket, we have file name. Okay, so file name or keys basically always includes the folder name, all the folders name, and the file name. Okay, the size of the file in kilobytes and e-tag and all those information is there. So if I press shift enter here, you can see I have defined a event variable. Okay, and this is exactly what I had printed on CloudWatch logs. You got this part?
Yes.
Okay, so I'll comment this now. And I'll comment this. So see, as per our plan, first of all, we need to identify the file type. Okay, what format of file we are actually getting. So to identify the file type, we need to get the file name first. Okay, because only in the file name we will have the file type. So if how to get a file name? File name is actually present here in this S3 object and key. Okay, this is how file name is being saved. Okay, so how do I get the file name? This is the file name that I want to get. So let's look at this dictionary closely. So we have this big complex dictionary. This is the dictionary starting point, and this dictionary basically has a key. That key is records. Records is the key. If you see on this label of records, I have no other keys. Okay, you can check on the label of records, I have no other keys. So I will simply come down and pick the records. Now if you see, when I pick the records, my output is a list. Okay, you can see my output is starting with square brackets, and it is a list type. You can verify same thing here as well. Record is of a list type. Okay, and then inside the records we have again one more dictionary. Okay, this is my dictionary starting from here and ending actually here. Okay, this is the place where my dictionary actually ends. So you can check, I mean, why I'm saying this, because this dictionary is directly ending at here. Okay, there's no commas in there. So this means this complete dictionary is basically placed on index number 0 of my list. Okay, so I will come down and mark 0 here. Okay, now we can see again I'm getting a dictionary. As I mentioned, we have on index position 0, we have a big complex dictionary. So we have reached on this level. Okay, starting from this level, we are now talking about what we need. Okay, we need this key. Okay, now this key comes under this key, and this key comes under this S3. So what if I start uh, solving them? So I will say S3 has to be small s. You can see I get now only getting this much information. Then I will say object. I will get again more reduced information. Okay, and if I say key, I get the exact file name. Okay, I get exactly the file name that I was looking for. Okay, this is how I get the file name. And see, the syntax is always going to be same to get the file name of a S3 from a S3 event into Lambda function. Okay, it is never going to change. Why I explained you step by step? So because you might get a different response syntax. This is one of the response syntax only. So you might get different response syntax in much complex dictionaries. So you should be able to solve them by step manners. Okay, so you should not be like, if somebody says you have to pull the let's say name of the bucket, you should be able to do so, because now this time you have to come here S3 bucket and name of the bucket. Okay, and if you want principal ID, you have to say S3 bucket owner identity and principal identity. Okay, so you should understand this, not memorize this syntax. Okay, do not try to memorize this syntax, even though this is a generic syntax, but try to understand this syntax. Same way I have got my key name, I have got the bucket name as well, because I would like to pass this bucket name into next function. Okay, so after that, what I am doing, I am simply creating a client of Lambda function to be utilized later. I am using os.parse.split. This is a function. Okay, this is a function. This function will take a string value and it will divide the string value based on the dot. Okay, so what it's basically doing here is it's going to pick up this thing. Okay, it's going to pick up this thing and it's going to divide this string into two parts. Okay, so before the dot, it's going to be file name. After the dot, it's going to be file extension. Okay, so due to this, we will be able to receive two variables, file name and file extension. I am printing those variables here. Okay, so again, I will take a pause if you have any questions.
What are above two lines, the 13th and 14th?
I am taking a date time, current date time. Okay, and converting the date time, it's going to be timestamp format and converting the date time into a string format. That's going to be in month, date, year, hour, minutes, and seconds format. Just a second now.
Okay. And this Lambda client we have created, right? Can we create this before getting this bucket and key details, or
Yeah,
after
you can.
getting these
So
details? We should
before using it, so I am using it here on line number 27. Before using it, you can create it anywhere. So all the variables that you are trying to define or use, actually you should define them before using it.
Okay.
Okay. So now as we have file extension, I will just verify the lower. I will just make sure that file is in lower. I mean, I want to make sure that file type are PNG, JPG or JPEG to be called as image. Okay. Because these are the only format those are supported by recognition. And I am saying lower because I want to make sure that file name is not in lower letter, mixed letter or capital letter. So everything I want to convert those into first lower and checking it with the lower PNG. So if this condition satisfies, that will be for our use case, okay, because we are passing a file name that is scan.jpg. It will satisfy this condition as we are saying, or one of these three should be satisfied. We are going to print this message that format is this, and we are going to call in the image processing, and we will actually invoke the recognition lambda function. Okay, nothing but one more lambda function we are going to invoke, and we are going to type the function name via ARN. This ARN is always present here on this lambda page. Here is the ARN of the lambda functions. Okay, so obviously I have taken the recognition lambda one, not this one. So I'll just create a duplicate here. This is the one I am using, and this is the ARN that I have used there. Okay, so what I am saying, I am invoking this function. Okay, I am going to run this function from inside this function. I am going to say invoke this function. Invocation type is going to be event. Okay, and I am passing these four variables to next function. Okay, I am passing these four variables in the next function, and these four variables are going to be present in the event variable. Okay, so this recognition lambda function, which is this function, is going to receive those four variables in this event variable. Okay, so whenever we call lambda function programmatically, okay, like using the invoke method, it can receive the variables using the JSON dumps that we have used here in key value pairs. Okay, and all those variables will be present here in event variable. Okay, I am printing this event variable for you so you can understand it better. Okay, then what I do next is, let's stay here. If you let me know if you have got this if condition, we are simply invoking one more lambda function and passing four variables. Those variables are, I am passing the bucket name that I have extracted here. I am passing the file name as a key that I have extracted here. I am passing a unique ID that is nothing but a date time format into a string format. I am passing a message. Okay, this is a hard coded message that this lambda function is going to be triggered by this lambda function, lambda file identity function. Okay, so let me know if you have any questions here.
this recognition function we have, it's a default function, right? Or do we need to create these?
We have to create this. We have actually created this. So let's say you want to run 10 lambda processing functions in sequence. You can use such kind of flow.
Okay.
Okay, so let's say you want to run one more Lambda function and one more Lambda function like that, and you are looking to skip the step functions. You can use this kind of format. So actually in this complete flow, we are learning how to set up a trigger that we have seen, how to call a Lambda function that we have seen, and some transformations that we will see here. Okay. So once this Lambda function ends, okay, it is going to trigger one more Lambda function, and that Lambda function is this one, recognition Lambda function. Okay, and as the doc string says, this function calls the recognition API and does the labeling of the image. Labeling basically means it's going to do the analysis of the image, and it's going to tell you what that image contains. Okay, and it saves the results back to the S3 file. Okay, so in this Lambda function, as I mentioned you, okay, in the last class, that no Lambda functions, I mean, or let's put it like this, all the Lambda functions starts from Lambda handler function. Okay, again remember this thing, all the Lambda functions starts from Lambda handler function. So if you think that in this code this detect labels is going to be triggered, it is not. Two reasons. First of all, this is not a Lambda handler function, and second thing, no call has been made to this function. Okay, it is just been defined on line number 7. So line number 7 is not going to be executed. So code is always going to look for this function called Lambda handler. Okay, the code this time is going to get started from line number 41. This event variable will have 4 things. Okay, from those things I am using bucket, photo. I mean, photo is nothing but a key. Okay, the source name, that means this name, this file name. This is I'm calling a photo now, not key. Okay, and a unique ID that we have received from the previous function, that is nothing but a timestamp in the string format. Okay, we only use these 3 variables for now. Okay, then what I do, again I take a latest timestamp. Okay, I convert the timestamp into underscore separated MDY HMS format, and I call it datetime variable. And again I create one date variable. Okay, so difference is like this will have time included, and this variable does not have time included, just for printing purpose. Okay, nothing else I'm utilizing here. Then I like see, before we write the file back onto S3. Okay, so for like we are right now on this stage. Okay, we have uploaded a file. My Lambda function identified the files type correctly. Okay, it's an image type, and now we are in the recognition Lambda. So this Lambda function is going to write the output back onto S3 bucket. Correct? So to write the output on S3 bucket, we have to mention a proper file name with location. Okay, so how we are building that file name is, okay, first of all I am saying target labels. So I will pick up this, paste it here. Okay, so this is my target file variable. Okay, I am picking up this and executing it here. Next thing I use os.pathname.replace. Okay, so I'll pick this up and paste it here. So what we are doing here is os.path.basename function, as I mentioned in the previous file entity also. This gives 2 things. Okay, this gives 2 things. Sorry, this base name gives only one and one thing. Sorry, my bad. Base name only gives only one and one thing. That is, after the last forward slash. Okay, let's say this is the complete key that we are passing right now. Photo, nothing but a key. From this particular string, after the last forward slash, it's going to pick up the file name. This is the file name that we are going to get. Okay, this is the file name that we are going to get, and it will be appended like this here. I mean, I cannot execute this here. That's why I'm explaining it like this. Okay, so you can think of it as a separate unit, not here. Okay, this is how it's going to become os.path.basename photo, nothing but a key. Okay, I hope you're getting it how it's coming like it's a event key. We are placing in a variable called photo. This is what we will get, and what we are doing next is replacing dot with underscore. Okay, as I mentioned, I want to save the file as a CSV format, not as a JPG format. So I will convert this into like this. This is my second thing, and my third thing is nothing but I will have one more underscore here. Then my last thing is date time. Date time will have something like this. And some seconds as well. Okay, seconds actually I'm not taking, and then I have plus dot CSV. This is what I have, and if I execute this, this is what I'll get as the final file name. Okay, so for examples, you can see here. Yes, why we have this target // because we want to make sure the file is being getting saved in the target folder. So every // that you make on the S3, it's going to convert into a folder. So okay, so if you say target / images, then one more // then what you will get? You will get target folder. Inside that you will get images folder, and inside that you will get this file name. So if you come here in the target, okay, this is my target // and then I have my file names. Okay, so if I just click on last modify, if I filter it or last modify, you can see it has labels car1 and then the same car1 like image name, date and dot CSV. This is what I'm converting here. So basically, before actually writing a file, I am writing a file name. Like in this file, I will write my data. This is what I am saying here. Okay. At this point, I am not writing something on S3. I am simply saying it that I will write on this location. Okay. After that, I call detect labels. That is this function. I finally call this detect labels. Okay. So the cursor, or you can say the control of the program, will come on line number 7, and this will receive 5 variables: photo, nothing but the path of the file, bucket name, target file that we just created, date that we just created, and unique ID. These all things we are going to receive here. Okay, so I'll just come down and let me know if you have any questions still here.
No, Suresh.
Okay. Okay. Then I will come in this function. I will create 2 more clients, one for recognition service, one for S3 service. Okay. Then what you can do, I mean, let's remove this. Okay. What we do next? I mean, simply I print the message that we are starting to detect labels for the key and from the bucket. So basically, I'm saying for this file, I'm accessing the labels. To detect the labels, again we have to use the recognition client. I call it client variable. So I will say client variable dot detect labels. So detect. Let's see this detect labels. Again, it's a Boto3 function. It gives you these details. Okay. This detects instances of real world entities within images, JPG or PNG. JPG is also supported as an input. Okay, this is the function of this. And if you check its request syntax, okay, this is the request syntax. Either it accepts image either in the bytes format or in the S3 object format. So we are passing in the S3 object format. Okay, so same thing I am saying here in my code. I am passing an image in S3 object format. From this bucket, I am mentioning my bucket name in a variable. The name of the key or name of the image, I am passing the key of the image. Okay. Then I say one more filter, max labels. Okay. Max labels, basically, if you come on this labels, you can see we are getting around more than 20 or 30 variables. Okay. 20 or 30 labels we are getting here. I am saying 10. That means I am only interested in the top 10 labels that we have got from the image. That basically means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I will only get these many labels in my output. I will filter all the others. One more filter criteria is that even though I have top 10 top 10 labels, but if their confidence like this, that means if their minimum confidence is not even 70%, reject those. Okay, so outputs like these, okay, output like these are going to be rejected because their minimum confidence via the machine learning algorithms is not even 70%. So this number 10 and this minimum confidence 70 is completely, choice of yours or choice of your project. It is not, there's no hard coded rule for that. Okay, that you have to use 10 or 70. You can use it 95 also, you can use 100 also, or you can use 2 also, as per your choices and requirements. Once I do this, I print the response. Okay, so I print the response that I get from this redact labels. So if you see here, like this is the filtered output for me. Okay, this results is kind of a filtered output for me, but actual response is this. This is the actual response. Okay, this has labels, this has a name, confidence score, their bounding was information, okay, categories, like it has multiple other information, and it is not readable. Okay, this is just for a single image, and it is not even a readable format. It's a complex JSON format. So we have to convert this complex JSON format into a normal format. So before I do this, I am simply going to run this. Okay, I am going to run it how? I am going to run it via file identity lambda. Okay, remember this. We are not directly going to trigger the recognition lambda. We have to trigger it via file identity lambda. I am going to comment this one out and uncomment all these things. Okay. Again, I will come on my bucket in the source folder. I will upload the file. I will move the file actually, not upload. I mean, for the you guys, you'll have to upload it because first time you will not have any images there. Okay. You can try it out with the different images. There's no worry about that part. Once I move this, I will come on CloudWatch. Come back to your log stream, and you will find one more log stream generated here. Okay. Open the latest one. You can see it prints out those messages like this is my file name and file extension. This is from file identity lambda. Okay, it is from this lambda function. So we got this message printed first of all. Then we get a print. The file format is .jpg, hence calling the image processing. Okay, this print we have got, and then my lambda function ends. Okay. Next thing is come on the reconciliation lambda, monitor, view in CloudWatch logs. Open the latest stream here as well, and you can see this is the response that we have got from that lambda function. Okay, I will take it up and convert this into proper format. Okay, let's actually create this in notebook. This is my response variable. Okay, this is my response variable.
So actually I will wait here if you have any questions till line number 21.
No questions, sir.
Okay, then yeah, then what I will do, see, this is the input. Okay, this is the like output. Sorry, my bad. It's output. This is the output for one of the images that I have got. Okay, and you know it's not readable. Like I cannot read this into some files or those things. Okay, so to convert this, we will need to do some transformations here. Okay, so first of all this information that I am getting for a one individual unit till here is kind of waste for me. I only need name and confidence score. I am not interested in the bounding box informations. Okay, I am only interested in the confidence score and name of the label, and I want to convert this into a CSV as well. So what I am doing, I am creating a final string variable. Okay, I am creating a final string variable. Then I am saying let's import the os.path. Okay, and then I am converting the image name into a, I mean this is the same image name that we have done previously. Getting the image name, let's say I'll create it like this. Okay, and my photo is nothing but this thing. As I explained you this part, this is a photo. Okay, I will call it here. Execute this. Photo is undefined. Oh, my bad. Okay, this is going to just simply if I print this image name, see it's just simply converting this can.jpg into can_jpg. Then I apply a for loop. Okay, so what basically we are doing here in this for loop. Okay, if you see here closely, I say for label in response labels. Okay, so if you see here, this is my response variable and it has only one key labels at the top. Okay, this is the like most top key of the this thing. I have no other keys out on the same label. Okay, I have no other keys on the same label. So this is my topmost keys. Okay, so I will use this key to loop it around. Okay, this is my label, and then it gives the information about all the labels. Like this is the list again, and this is my first label. This is my second label, and like that. So I will pick up the first label first. Okay, I will pick up the first label first. Okay, so how I'll do it? I will say label. Here I'm not applying for loop. I'm simply saying response labels. Okay, I think it is capital L. Okay, if I print the label now, you can see it is a list type. So you know what this for loop is going to do? It's going to pick up all the items of this list one by one. That means first of all, it's going to pick up 0 index, something like this. Okay, it's going to pick up the 0 index. This is what I have in the first iteration. Okay, this is what I have in the first iteration. Second iteration, I will have next things. Okay, third iteration, I will have next things. Okay, so here now what I'm doing here, I'm printing unique ID. So let's create this unique ID also. I will simply type some random variables here. Let's copy this properly. I will create this some random unique ID. Okay. After my unique ID, I pass this name. Okay. This is my, I will say, temp string. Okay, you can see I will print this temp string as well. Temp string to print. This is what I'm getting. Next thing that I have is image name that I got from the base name. So I'll add this also. Then I have plus image name. Okay. If I do this, I'm getting can.jpg. This image name variable is created here using the os.path base name library. Then from my label, I pick up this thing, label's name. Okay, I pick up my label name. So if I, this is the thing I am getting. So it will be for 0 index first. Okay, I will get can here. So I get then list indices multiple slices not integer. Where? Something I'm doing wrong. Line 36. Okay, I have to say label.0.name. Sorry, my bad. It's the 0th index. I have to mention the index as well. Okay. Then we get the proper things. Then we need to get the confidence score. So I will just get the confidence score from. So basically, from the complex dictionary, I am picking items what I need, and I'm simply appending those items into a string. Okay. That is the overall activity that we are doing here. I am simply picking up the items that I need. I'm appending those into the string. And as this label confidence is stored in the float format, okay, and float cannot be appended using the plus sign. Hence, we have to convert that into a string part. Okay. Now we will get this. Just integers. Okay, it has to be 0 again. Now we will get this thing. Okay. Then we will get all these like hard-coded object and date. So your output, okay, your final output is going to something like this. Like this is the example I have given. Okay, your final output is something going to be like this. We have to come in the Lambda mini project, target folder, sort this based on the last modified. This is what I will get 608. Like no, wait. This is not the one. This is the one. Okay, we will get this one. Okay, so if I download this, you can see we are getting proper output here. Okay, all the labels have been detected correctly. So we get proper format like this. Okay, now if you see I have a /n here. Okay, if I do not use /n, what's going to happen? So all the new records are not going to be added into the new line. They are going to be added into the same line. So something like this is going to be happen if I do not use /n. Okay, this is the output you will get without /n. As we want to have new rows on the CSV for the new images or for the new labels, I would like to have it like this format, not otherwise. So I will leave you with this code for 2, 3, 5 minutes and let me know if you have any questions. I mean, just 1 more minute, huh? At the end, once I get this final string generated, okay, I get temp string, I append this temp string into final string, and then I call put object. Put object is nothing but S3 client function to write the file onto the S3 location. So we will mention the bucket, in which bucket you would like to write. You will mention the target file. So we have already created this target file variable. Okay, it is this location. Okay, it is this location. on line number 51. Then we mentioned what data. Okay, so in body part you will write what data. The data is actually nothing but final string. This is the data that I would like to write. So you can go through this code, only few lines of code, but might be a tricky one for you as you are the new beginner. So yeah, go through this carefully and let me know.
I don't have any doubts as of now, Chalish.
Okay, so I mean this is the complete process for this Lambda function. So what we have gathered from this Lambda function, how to work with triggers, how to do some transformations, how to connect with other services using the client, how to call different functions, how to create a kind of flow, how to define functions inside the Lambda functions. Then the one I shared with you, I am simply going to go on top of that. That is file trigger backup to S3. So in this one we are again picking up the file name from the event, picking up the file key from the event. Okay, this is the source file name and source file key. Idea here is to back up the whole data. I mean, forget about this. I'll explain you in the next class separately if you have any questions, because I have to cover up some other things. Have you tried to go through this code? Have you tried to go through this code previously?
Not this one, Chalish. Other one, the one we have done in other class. So
Okay, I'll explain you this in some other class. Actually, it's a very simple. Let me just do it a high level overview. So we are simply picking up the from the bucket like event name. We are picking up the source bucket name and the file name and printing those, same logic. Then we delete the data. So basically this code is going to delete all the data from the target file, sorry, target destination bucket, and it's going to place all the data from the source bucket. Okay, it is going to place all the data from the source bucket. Remember this. So to delete that, first of all, I say list objects. Okay, which list objects I want to do, like from which bucket I would like to do. I will say destination bucket. Okay, whatever is the destination bucket name, as it says AWS data engineering course here. Okay, as it says this bucket, you have to like this particular line number 23 to 26 will delete the data from this destination bucket. How it will delete? It will going to list all the objects, and okay, and from that it's going to pick up the key of the object. Okay, so when you say list objects, it gives you I mean, let's check its response type. Okay, so we will get this contains and some other keys, okay, on top label. So I'm simply picking up the contains from the top label, and I'm interested only in the key. Okay, so from contains one by one I will get all these its list type. All the contains one by one I will get in this variable called object or obj, and from that obj I will pick up the key. Okay, I will simply print the key. So I will say currently deleting this particular object or currently deleting this particular file or key. I'll print that key and I'll simply use the delete object. I'll say destination bucket and the key. So for loop is going to list all the items from the destination bucket, and one by one it's going to delete those. Same thing is happening below. This time the list objects is on source bucket. Again we are having for loop same way, but this time not to delete the okay. After print I am not deleting the file, I am using a copy source. Okay, I will create a copy source and I'll copy the object onto the destination bucket. That is all I am doing. I will copy the content from the source bucket and I will push the content onto the target bucket. Okay, so this code basically simply gives you how to copy the file, how to delete the file, how to list all the files, and how to uh, do a kind of a backup process. And this kind of processing is actually happens quite a time in the production as well, where once you process the file or once the file comes to you, you would like to have a backup of the file automatically created for yourself. Just in case if you corrupt the file, or if you misplace the file, or if you delete the file, you already have a backup. So I will suggest you to please go through this code this weekend, and if you have any questions you can let me know. Otherwise try to execute this. Okay, try to execute this and let me know if you face any challenges. Okay, I am here to help you, but I don't want you to spoon feed complete things. That's why I have given you the overall context of this code, and you can try it out. Obviously before trying out this code you'll have to set the IAM permissions. That will need only and only one thing, that is S3 full access. Okay, second thing, you will have to place a trigger, and you have to be sure that you are not moving the data into the same bucket. Okay, your source bucket and your destination bucket should be different. You have to add the trigger on the source bucket. So I'll share these codes with you, all codes. You already have, I think, backup file. Yes, backup is already there. File identity lambda and recognition lambda, this one. Two more functions you have to go through. Please try this out. You know how to create function, you know how to attach policies. There are few other things, as those two guys have not joined, so I will continue it on Monday with the Lambda functions. I'll finish up the Lambda functions on Monday and start with the AWS Glue as well. So I'll request you to please practice and come up with some questions if you have any. So yes, you have something for me now?
Yeah, Chalo. So, in interviews, if we say that we have worked on Lambda functions,
Mhm.
will they ask us, like, will they give us any use case and ask us to write the functions?
No, ideally no. But they might ask you to write some Python code snippets, not complete Lambda function.
Okay, and these functions we are using in Lambda, right? So generally we would not remember this. We have to go through the like Porto 3 and other
Document only.
modules and we need to recognize the functions, right?
Yes. You cannot remember all of these. See, once you work on these functions on day-to-day basis, some of these libraries which you use continuously, you will start memorizing all of those by default. But now you can not memorize all others by heart.
Okay. And what type of questions we can expect from this topic, AWS Lambda?
What is Lambda functions? What kind of use cases Lambda supports? How you use in this real-time projects? What kind of function you have written in your Lambda in your projects, like those? These can be the interview questions. Why Lambda not AWS Glue? Okay, or why AWS Glue not AWS Lambda? That can be one of the question.
Okay.
Okay, in that case, you have any more questions? I'm clear. I'll wait if you have any questions.
No, Jalesh, I'll go through the codes. I'll try to execute those, and if I face any challenges, I'll let you know on Monday.
Sure, sure, sure. Okay, then thanks, Aishwarya. Bye bye.
Yeah, thank you. Bye.